Hello everybody, today we're going to take a look at three special quadrilaterals. In fact, they're three special parallelograms, and they are going to be rectangle, rhombus, and square. So for this, you're going to need your notes again, and those little cutouts need to be taped in your notes on separate pages, rectangle, rhombus, and then square. And we're going to go ahead and talk about those properties that each of those shapes have. So in your notes, you should have your rectangle taped in there, or glued in there. And your rectangle is this picture right here. This is rectangle ABCD. Now, if this is a rectangle, then certain properties will happen in all rectangles. And we need to identify those properties again. So again, because a rectangle is a parallelogram, opposite sides are both equal and parallel. So think about your rectangle. If we were going to mark him up here, we would say that this one is equal to this one and parallel. So one slash and maybe a couple triangles there. And this might have two slashes and two slashes and one triangle for parallel to this one. So in a rectangle, opposite sides are both equal and parallel. This is the same, or the case is the same for just general parallelograms. So what else happens in a rectangle? What makes a rectangle special is that he's more than just a random parallelogram. He has 90-degree angles in all of his corners, okay? So all of the corners here need to be marked with 90 degrees. That's what makes him a special type of parallelogram. He fits the description of a parallelogram, except he has 90-degree angles. So then what else happens? Well, the diagonals will also be equal in length. So that means because the rectangle's no longer slanted like the parallelogram, he's standing upright with 90-degree corners. That means that all of these little pieces of diagonals in here will also be congruent to each other. All the pieces are congruent. That didn't happen with parallelogram. Two pieces were the same and then the other two pieces were the same. But because this is a rectangle and he's no longer slanted, that means that all of those pieces in there will be congruent to each other. I'm going to mark him with an E, and if you want to, you can make that list of the properties right next to here or identify the portion of the shape that we're talking about, but you wouldn't have to if you just want to look at your visual picture. Okay, so the diagonals are equal in length. And then our fourth property is that the diagonals would be bisected. So they are cut in half, okay? That's what we're talking about right here. So those little slashes that we marked on the last one, they're still good. Maybe we should also be clear that A to D, or B to D, and A to C would be the same length. Okay, so maybe up on this other one, I might add that one in there. BD is congruent to AC. Okay, and the diagonals being bisected, we can go ahead and say that that's marked in our picture. Or you could list BE is congruent to ED, which is congruent to AE, which is congruent to EC. Those are all little congruent pieces inside of that picture. So that's what makes rectangle a little bit more special than just a general parallelogram. Now let's consider the case of rhombus here. Rhombus has some special properties too. In a rhombus, the sides are all congruent in length, okay? So that means instead of having opposite sides that are equal, all the sides are equal to each other. A rhombus is like a parallelogram, but with all the sides the same length rather than being stretched out, okay? He's slanted like a parallelogram and all those things, but his sides are all the same. So what about opposite angles? Are they still congruent? They sure are. He's a parallelogram. Okay, so we could mark that in our picture. This guy is congruent to this guy, this one's congruent to this one, and so on. Okay, now consecutive angles are still supplementary. So angles next to each other will still make 180 degrees when we add them together. The diagonals are bisected, so they're cut in half. Now, because this one's slanted a little bit, they aren't all going to be the same length in there. So this one might have 3 slashes and the other pieces would have 2, but they're cut in half, okay? And then the diagonals are intersecting to make a 90-degree angle in the middle, or they're perpendicular. The diagonals are perpendicular. So that means in here, at angle E, there be some right angles in there. Okay, 4 of them. So they're intersecting or they're crossing in there to make a 90-degree angle, right angles. Okay, and last but not least, this one's kind of tricky to draw in your picture, but the diagonals bisect the opposite angles. So maybe if you want to use the numbers that are in your picture, that means angle 5 right here, he's congruent to angle 6. Okay, so angle 5, oops, angle 5 is congruent to angle 6. And also, they are also congruent to angle 3 and angle 4 because those would be the opposite angles next to them. And so basically those angles in those corners are split into 2 equal parts that are congruent to the opposite big angle across from them. So we could say the same thing about angle 1 being congruent to angle 2, which is congruent to angle 7, which is congruent to angle 8. Okay, lots of congruent angles in there. And if you want to draw 2 separate little 1 slashes through here, 1 slash, 1 slash, 1 slash, 1 slash, we're talking about those angles being equal as well as the angles across from them. Okay, so with rhombus, some new things are happening. We got that 90-degree corner in there. We got all the sides that are the same. That didn't happen in a parallelogram or a rectangle. So our last shape is square. Now I want you to think about this like if Mr. Rectangle got married to Mrs. Rhombus over here. Miss Rhombus, Mr. Rectangle, they got married and they had a child. Okay, that would be the square. Okay, square is so special. He has all the properties of all the shapes that we've talked about so far. So square has a lot going on. Okay, with square, you're going to need to make a longer list here, and I'm going to list just the properties about the sides, angles, and then diagonals because there's so many because he's so special. Okay, so the sides are all congruent in length. They're all equal. So on a square, all these would be the same, which is just like the rhombus, okay, but the rhombus was slanted. And opposite sides are still parallel because he's still a parallelogram. So I'll fill in the parallels. Let's see what else. Angles. All the angles in the corners of this shape are 90 degrees. That's a rectangle property, okay? Rectangles have 90-degree corners, so square gets that property from Daddy Rectangle. Okay, all the angles are the same, obviously, if they're all 90, right? Opposite angles are the same, and opposites, and the consecutive ones. Whoops, can't spell. Consecutive. Obviously, if all the angles are 90, that the opposite and consecutive ones would be the same. And then also, kind of an interesting fact, just because he's a parallelogram, he should still follow this sort of rule. Are the consecutive angles still supplementary? Well, yeah, if they're all 90, then that means corner to corner, corners next to corners here, will still add up to 180 degrees. That still makes sense. Okay, let's talk about the diagonals in there. The diagonals are equal in length. Okay, that means from A to C, this corner to this corner, okay, those are the same length. He's not a slanted shape, and slanted shapes would have different lengths for those diagonals. So the diagonals are equal in length, and when they're equal in length like that, then they're bisected. So that means right here, 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 those would all be the same length. Okay, diagonals are intersecting to make 90 degrees or perpendicular on the inside there. So that's a rhombus trait. We also have 90-degree corners inside when those diagonals are drawn. And then the diagonals still bisect those opposite angles. Okay, they bisect the opposite angles. So that means our 90-degree corners here will be cut in half at 45s. That's the first shape where we can actually put a number to it, okay? So that's what we're talking about here with square. Now let's do one example or just see if we can kind of put it all together. This is a square. What is the length of the sides so that we can find what is the area then? So here's a square. drawn here, I have one little piece marked with a 7. Now, using what we know about squares, that little piece is on the diagonal. And I know that diagonal lengths are all the same in here. So all of those little pieces right there would also be 7 centimeters. But I want to know what's the length of a side of that square. Well, what could we use to figure that out? Well, hey, you know what? Inside the square here at the diagonals, that's a 90-degree corner. So what I have here is a nice little right triangle right there. Okay, we could use that to help us find that length of x up there. And if you remember, the little corners here of our square would be 45-degree angles because the opposite angles are bisected, okay? The diagonals bisect those angles. So those would be 45s. So this is a special right triangle. And in special right triangles, we know the hypotenuse equals the leg times the square root of 2. So the hypotenuse in my right triangle is what I'm trying to find. The leg is a 7. It looks like that missing side is 7 times the square root of 2 would be 7 square roots of 2. So this is the side of each square. So it would be 7, or each side of the square, 7 square roots of 2, 7 square roots of 2. Hey, that's pretty good. So we know the length on the square here, what each side is. Now how would you find the area? Area is equal to, well, length times width for a shape like this. So the length is 7 square roots of 2. And we take that times another 7 square roots of 2 for the width, length and width. And then we go ahead and figure this out. Numbers outside here, 7 times 7, 49. The square root of 2 times the square root of 2 makes the square root of 4, which you might look at and go, wait a minute now. Square root of 4, that's just a 2, silly. So this is like saying 49 times 2. 49 times 2. So the area would be whatever 49 times 2 is, and that would be 98. So the area equals 98. And I'd label that with centimeters squared, okay, or square centimeters. And I should go back to my sides and make sure that I labeled that with centimeters. Okay, so this is what we're talking about. We're talking about taking these properties, applying things we already know about right triangles, trigonometry, special right triangles, and continuing to use those when we branch off into these other shapes. Okay, thank you for taking good notes, and we'll continue to work.